Hello everyone, so in this video we are going to solve a question of LeetCode, that is Pascal's triangle. So let's start with the problem statement. Given an integer nums rows, return the first num rows of Pascal's triangle. In the Pascal's triangle, each number is the sum of two numbers directly above it as shown in the figure. So basically in this question we have given an integer that is nums rows and we need to return a 2D vector, right? We need to return a 2D vector to after forming a Pascal's triangle, right? And basically we have given the number of rows here, right? We have given the number of rows. So let's quickly see the first example. So in the first example we have number of rows, that is n is equal to 5, right? So let's make a Pascal triangle here. So the Pascal's triangle for n equal to 5 would look something like 1, then 1 and 1, right? Then here we will get 1, then 2, then 1, then we will get 1, right? 1, 3, 3 and 1, then we will get 1, 4, 6, 4 and 1, right? So what can we conclude from here is that this number, right, this number is basically the sum of two previous one, right? It is basically the sum of two previous one. Similarly for this one, we do not have any number here, right? We don't have any number here, so we will just add, let's consider this as 0, so 0 plus 1 is equal to 1, right? So this is basically the sum of two previous one, right? So if we write this in proper form, right? If we write this into a proper form of 2D vector, so it will look something like 1 1 1, then 1 2 1, then 1 3 3 1, then 1 4 6 4 and 1, right? So this is the proper 2D form of this Pascal's triangle, right? So let's find out few observations from here. So the very first observation here is the first element of each row, right? The first element of each row is always 1, right? This is the first observation. Similarly, we can also see that the last element, right? The last element of all the rows is also 1, right? So we can conclude two things from here, that the first element, right? The first element and the last element is always equal to 1, right? These are the two things. So let's see what are the indexes for this. So the index for this first row is, let's say, each row is represented by, or we can say in the each iteration we iterate through I. So let's say we consider this as I, right? The rows is considered this as I, and the column is fixed, right? The column is fixed, so the column is equal to 0, right? So what each index would be, let's say we make a answer vector for this answer 2D vector. So answer 2D vector will be answer, this I will be changed for each row, right? And the column is same, so this would be equal to 0, right? And this is equal to 1, right? Similarly for the last one, right? For the last one, so what can we say, right? What can we say for this? Let's say this is the first row, right? This is the first row, so the last element of this first row, right? The last element of this first row is 1, right? Or what we can say is, let's say if we start iteration from I equal to 0, right? If we start iteration from I equal to 0, this is 0, this is 1, this is 2, right? Then this is 3, this is 4, right? And similarly for this we have 1 0 1 2 3 and 4. So what can we say? This 0 comma 0 index, right? This is 0 comma 0, this is 1 comma 0 1 comma 1, this is 2 comma 2, right? This is 2 and this is 2, so this is 2 and 2. Here also ij value is 3 and 3, and here also this is 4 and 4. So what can we say here is that this is answer I is same and j's value is also same, right? Right, so what can we say is in both this condition we will be adding 1 into our this vector, right? So till now we have solved the condition for the first element and the last element. Now let's see for the middle elements, right? So what are these middle elements and how can we compute the value of this? Let's see. So to compute the value of these middle elements, we can say that these are the sum of the previous two, right? These are the sum of the previous two. So let's say for this 3, this is the sum of 1 and 2, right? This is the sum of 1 and 2. So what we can say is, let's say the index of this is, that is the index of 3 is 3 comma 1, right? This is 3 comma 1. The index of this is 3 comma 1 and the index of 1 is 2 comma 0, right? This is 2 comma 0. So what we can say is the difference between both the indexes is of minus 1, right? So what we can conclude from here is that this should be equal to answer of I and j, right, would be equal to answer of I minus 1 and j minus 1, right? This is I minus 1 j minus 1 plus the second one, this is 2 comma 0, and for this 2, right, for this 2 this is 2 comma 1, that is 2 comma 1, this is 2 comma 1, and for this 3 we have 3 comma 1. So this 1 and 1 are same, this 3 is only decremented. So for this answer I minus 1 j minus 1, and the second thing we can say is this is answer I minus 1 and j, right? So this will give us the values of the middle one and this will give us the value of first and the last element. So through both this equation we can easily form our Pascal's triangle, right? So I hope the approach is clear to you. Let's quickly move to the coding part. So yeah, let's move to the coding part, and we can also see one more thing here is that let's say for this each row the number of elements, right, the number of elements is incremented by 1, right? The number of elements in the each row is incremented by 1. So what we can do is we can initially declare a 2D vector, and for each 2D vector we can resize each vector by the index number. Let's say for I equal to 0, right, for I equal to 0 we have one element in the vector, that is I plus one element, right? So what we can do is we can resize the vector with I plus 1. Let's quickly code the solution. So for this let's first take vector of vector integers and let's name it answer, and let's initialize it with size nums rows, right? Now let's run the for loop. For int I equal to 0, I should be less than nums rows, that is num rows, and I plus plus, right? So this will, we are just traversing the n number of rows, right? This is the num rows. So let's first resize the each vector, right, with I plus 1 value, right? We have already understood this in the example. So let's resize, that is answer of I dot resize I plus 1, right? Now let's first initialize these values, right? Let's first initialize these values, the first equation, right? So let's write the first equation here, that is answer of I 0 is equal to answer of I is equal to 1, right? So this will initialize the value with 1 for the first and the last index of the each row. Right, now let's calculate the values for the middle one. Right, so we are writing the second equation here. So let's run a for loop for this. Since we are taking the middle elements, so we don't be considering the 0th index here, and we won't be considering the ith index here, right? So we will be running basically the loop from 1 to I minus 1, right? So let's run this for loop here. So for int I, let's say this is j, because I is already declared here, so j is equal to 1 and j should be less than equal to I minus 1 and j plus plus, right? Now let's write this equation, this second equation here. So there should be answer I j is equal to answer of I minus 1 and j minus 1 plus answer of I minus 1 and j, right? This will add the middle elements for us in the 2D vector, right? So let's return the answer from here and this should work fine. Let's just run it. Okay, we did a spelling mistake here. Yeah, it's running fine. So let's just submit this. So it's working fine. So let's calculate the time and space complexity. So the time complexity for this solution is big O of n square, because we are traversing through each n rows and at max we are just traversing to n column. So this should be equal to big O of n square, and the space complexity is also big O of n square, because we are just storing all the n rows and at most n columns into this answer vector, right? So I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.